Good morning, geometry students. Today you will be learning about points of concurrency, the different centers of a triangle. There are many points of concurrency, many different centers of a triangle, so today we will focus on the circumcenter, which is the point of concurrency for perpendicular bisectors. You will be using your knowledge of how to construct perpendicular bisectors to help you find the circumcenter. A point of concurrency is the point where multiple lines intersect. To help you remember this, think about the root word concur. Concur means to agree. I concur with you. He concurs with them. That means I agree with you and he agrees with them. In this case, where the lines intersect, where they agree, is the point of concurrency. The circumcenter is the point of concurrency for perpendicular bisectors. When you have a triangle and you draw the perpendicular bisectors, the point where the perpendicular bisectors intersect, where the perpendicular bisectors concur, is the circumcenter. We will be using GeoGebra to help us learn about circumcenters. So please go to GeoGebra and start a new calculator. When you open GeoGebra and start a new calculator, check your settings in the main menu. Make sure that your rounding goes to 2 decimal places only and that your labeling is for no new objects. Save the settings and exit out of the settings. Also sign in to GeoGebra so that you don't lose any of your progress. Sign in using Office 360 so that you can sign in with your school account. All right, now that you have signed into GeoGebra, I want you to make a triangle with vertices at -4, -2, 0, 3, and 3, -3 using the polygon tool. Now that you have your triangle, use the Move tool and show the labels of the vertices. Also use the Move tool to make your triangle opaque, meaning there's no shading in the middle of it. So click on the triangle, click the paint option and move the bottom bar to 0. Now your triangle has no shading in it. So with this triangle, we need to figure out where the circumcenter of the triangle is, which means we need to draw the perpendicular bisectors for each side of the triangle. Since there are 3 sides, we need 3 perpendicular bisectors. In Delta Math, we drew perpendicular bisectors for 1 segment. Here we have 3 segments. So just focus on 1 segment at a time. Let's start with segment AB. First, make 2 congruent circles that intersect. Use the circle with center and radius tool. Put the center of the circle at point A and make the radius 3. Make another circle at point B with a radius of 3 as well. Notice that the 2 circles do not intersect. You need to make circles big enough that they intersect. Okay, so undo those 2 circles and try again. Make a circle at point A, change the radius to 4 this time, and make another circle at point B and also have its radius 4. These 2 circles do intersect. The second step is to find the intersection of those circles, of those arcs. Okay, so use the intersect tool and select the two circles. This is where the two circles intersect. Third, draw a line through the intersections to make the perpendicular bisector. So using the line tool, select the two intersection points to make the perpendicular bisector. This is how you make the perpendicular bisector in GeoGebra. But before we move on, let's check to make sure that this is in fact a perpendicular bisector. So let's see if that line intersects the segment AB at its midpoint. Use the intersect tool to find the intersection between the segment AB and the line. This point should be the midpoint. To check that, use the distance tool and find the distance between the endpoint and the midpoint, the other endpoint and the midpoint as well. If those two distances are exactly the same, then you did find the midpoint. So you can use the move tool to move this information out of the way. You can also use the move tool to change the letter F, what they labeled it with the letter M for midpoint. Let's do M1 for the first midpoint. Since this line is a bisector because the segments on either side are congruent, let's check to make sure this line is perpendicular. So use the angle tool. Find the angle between the line and the segment. So select the segment and select the line. Notice that it gave me this full circle. Instead of selecting the segment and the line first, try selecting the line first and then the segment. All right, so that gave me 90 degrees. So that does mean that this line is a perpendicular bisector of the segment AB. Since we still need to make two more perpendicular bisectors, let's clean this up a little bit. Go to the calculator tool at the top right here and uncheck the two circles that we drew. Also uncheck the two intersections that we drew, because those points aren't important anymore now that we have the perpendicular bisector. I'm also going to move the M1 and the 90 degrees so that it's easier for me to see. Okay, now I want you guys to find the perpendicular bisector for the line AC and the perpendicular bisector for the line BC. Now that you have all three perpendicular bisectors, find the intersection of those lines to find the point of concurrency, which is the circumcenter. Use the intersect tool to find the intersection of those lines. You can just click two of the lines. This point right here is the circumcenter of the triangle, is the point of concurrency for all three perpendicular bisectors. Okay, so what I want you to do is to change the point to a different color using your move tool. And I want you to use the text tool and put anywhere on the page this definition. The circumcenter is the point of concurrency for perpendicular bisectors. You could also use the move tool and change the color of it to the same color as your circumcenter. So let's clean this up one last time by turning off the grid and turning off the axes. So what's so special about the circumcenter? I want you guys to find this out. Draw segments from the vertices to the circumcenter. Find the length of those segments. What do you find out? Use the text tool again and complete this sentence. Change the color of the segments connecting the vertices to the circumcenter to be the same color as the circumcenter. Also change the color of the lengths you found for those segments to be the same color as the circumcenter. When you are done, snip your drawing and insert it into the engagement notes section onto the page Circumcenter. For homework number 14, you're going to start a new GeoGebra calculator and find the circumcenter of your own triangle. When you are done, snip your drawing and insert it into the log homework section onto the page homework number 14. Good luck, you guys.